All right, good morning. Welcome to the Virginia Tech Science Festival. I want to thank you all for being here today, both those in our studio audience and also those watching online. Good morning. So glad you're here. My name is Phyllis Newbill. I direct the Virginia Tech Science Festival, among other things. We are filming today's presentation, so the 360 camera is here and can see the full room. Just want to make you aware of that while we're here. That is being live streamed and will be available to the public afterwards as well. When we finish today, we especially want to hear from the young people in our audience. So those under 18, we have an evaluation for you following the talk. Please do turn off your phones if you have anything that would make noise during the presentation. If you have questions, we're going to hold the questions till the end, but during question time, for the folks online to be able to hear your questions, you have to talk into the mic. So if you'll raise your hand, I'll come to you, and I'll hold the mic so you can ask your question. If you're online, I hope you will also ask questions using the questions link, and I'll get those on my computer here and ask them. And the Virginia Tech Science Festival has been going on for a number of years now. There's lots of parts to it. Today is one part. In addition to this, we also have a number of field trips, online meetups, and all kinds of fun. I do want to thank some of our partners that are involved, and I'm thanking different partners every hour. So this time I'd like to recognize the Center for Communicating Science and also the College Access Collaborative, who are some of our partners on making the Science Festival happen. For this hour, or this 30-minute presentation, we are so lucky to have Sam Silknetter with us. Sam is a graduate student in biological sciences, and he is also a member of the Communicating Science workshop class. And so he's going to be talking to us today about how whether freshwater fish are in danger from a changing climate. There's a question for you. Sam, I'll turn it over to you.
Perfect. Well, thank you so much. As Phyllis said, I'm Sam Silknetter. I'm a third-year PhD candidate in the Department of Biological Sciences, and I work with Dr. Merrill Mims. So this talk, as Phyllis said, are freshwater fish in danger from a changing climate. I'm actually going to a national conference, the American Fisheries Society, later this afternoon to give a different version of this talk. But to be honest, I'm so excited to be here with you all and to get to talk to this audience. Very, very excited about it. And so I think, first off, the first thing that I want to acknowledge is some of my collaborators. And so I'm really excited to work with three awesome women in STEM as part of this research team. All of them are really amazing mentors for me. So first is my advisor, Dr. Merrill Mims. She's here in the Department of Biological Sciences, and she's just been awesome. She's really spearheaded a lot of this work that I've sort of come in and been doing as part of my dissertation research. I also have a collaborator, Abigail Benson, who's with the U.S. Geological Survey. And Abby's great. She's a data scientist and sort of a wizard when it comes to this big data. And I'm really excited and so grateful that I get to work with her. And then there's also Dr. Jen Smith. So she's currently at the University of Texas, San Antonio. But before that, she was a researcher here with two different advisors at Virginia Tech in the department. And so really excited to get to work with all of them and had to shout them out first and foremost. So let's get into the really exciting parts of this talk. And so global climate change and species vulnerability. So these are probably different terms that you may have heard, but I think it's really important to be able to contextualize what do those mean, especially as it relates to what I'm going to talk about. So first off, let's introduce some of these different threats that we all might be familiar with. So we've got things like pollution, rising sea levels, global warming, and then we have this crazy increase in severe weather events. And so if you all remember Texas, earlier this year, there were these crazy freak ice storms, and more these severe weather events are becoming more and more common. And we understand maybe how they intersect or how they can affect humans, but how do they affect species? And that's something that I'm really interested in, and that sort of leads into the second concept of species vulnerability. And so when I talk about vulnerability throughout the rest of this talk, I'm talking about species that can be in declines, and so we need to be able to help them, because if we don't, these guys might go extinct. And so with this idea of sort of these different threats to species vulnerability, it comes up with this key grand challenge. And this is something that really motivates a lot of the research that I do. And so this is the challenge that we face. And so I want to show an image that I think you're all probably have seen at least once or twice before, maybe with a Coca-Cola commercial, but here we've got polar bears. And so when we think about polar bears, if we were to close our eyes, I think you can imagine them. They're these big white bears. They've got these gnarly teeth. You know that they live up in the Arctic potentially, and you probably see pictures like this, okay, where we've got maybe a shrinking sheet of ice, and we've got these bears there. And so when we think about conservation and protecting species, we oftentimes think of these really big, charismatic animals. Maybe you think about a panda too, but I think you definitely have at least thought about these polar bears once or twice. But let me show you somebody else that maybe you haven't thought about. So this guy is the green blossom pearly mussel. And this is a species of freshwater mussels. And freshwater mussels, if you don't know, they're super important because in rivers and streams, there's all sorts of sediment that sort of works its way through, but these guys do an amazing job of filtering all of that stuff that's coming through. And so they take dirty water in, take all those nutrients and spit the dirty water out. So they're really awesome, really helpful, and they're really important for trying to maintain the health of rivers and streams. However, these guys don't get a lot of love from a conservation standpoint. And so you probably haven't seen one of these green blossom pearly mussels, especially the young folks in the audience, because these guys went extinct 35 years ago. You used to be able to find them right here in the New River and in this part of Southwest Virginia, but no longer. And so I think if you sort of think about this differences between the polar bear and this little pearly mussel, you can try to understand this main challenge that we've got. And so this challenge is that we need to be able to effectively prioritize our conservation resources. And so I think that is something that, again, really motivates a lot of this work. And I was trying to think through what's an analogy that I can really hit this home with all of you. So I was trying to think, what does everybody like, especially young people? And it's like, of course, pizza. We all love pizza. Raise your hand if you like pizza out there in the audience. Folks online, every single person has their hand up, of course. Even if you're gluten-free or vegan, we've got options for you. But so let's think about this pizza as a conservation resource. So I'll put a black box around it, or a black circle, because we have a limited amount of these conservation resources, and so we've got a limited amount of pizza. And so we think about it in terms of humans. Imagine that we've got these 8 people. Okay, question for you out in the audience. How would you split up this pizza if you have to share it among 8 people? Just shout it out. Any ideas? Split it into 8 slices. Absolutely. So that's pretty straightforward. Now, let me give you another example. What if instead of 8 people, you've got 32 people, and you only have 1 pizza to split? Do you split it into 32 little slices? Is that fair? Well, we don't really know. So let's imagine in this scenario, you've got 32 people. What if I told you that the first 16 of these people just went to Benny Marzano's? Each of them had their own 28-inch giant pie. Well, maybe they don't need this pizza. And then maybe you've got 4 other people that are going to be going out to dinner later tonight. And what if these last 8 people, down here in the bottom, let's see if I can get my clicker. There we go. So imagine these last 8 people, they haven't eaten all day. And so if you knew that information, you'd say, well, wait, we shouldn't split it into 32 slices. We should split it into 8 like we did before and give it to the people that need it the most. And so think about that analogy. And that really, I think, relates to how I think about freshwater fishes and species conservation. The question we can ask humans is, who needs the pizza? You can learn about them. Have they already eaten? Will they eat later? How hungry are they? We can figure that out just by talking to one another. But if we're trying to ask the same question for these little fishes in these streams and rivers, it's impossible. And so what we have to do is try to identify species that are vulnerable. Think about the species that are hungry and that want that pizza, that they need those conservation resources. And so this lands and sort of transitions into this other question that I'm really interested in, and really is kind of the bulk of this talk. And that is, what tools can we use to help address this challenge? And so today I'm going to be talking about a tool that we've developed as part of our research team. And so I'm excited to sort of get into this a little bit, going to get in the weeds. So I'm talking about natural history. And so when I talk about that, that's really just kind of species and what do we know about them. So it's not surprising to any of you that we live in a data-rich world. Technology is constantly changing, and it's really exciting from a research standpoint because it opens up new possibilities. And so one of these natural history data sets that we like to use is called GBIF. And this is the Global Biodiversity Information Facility. And I won't get into too much of the detail with this, but what they do is they collect these species observations. Has anyone heard of iNaturalist? If you have, raise your hand. Okay, a few hands, not as many as for the pizza, but iNaturalist is this awesome citizen science tool. And so you can go out, and if you've got a phone and it has a GPS, you can take a picture of a critter and you can submit that record. And so what GBIF does is it collects all of these records, not just from citizen science, but also from museum collections and all sorts of professional scientists. And what they do is they make these records available so you can tell when a species is found in a given time and in a given place. And so GBIF has more than 50,000 of these different data sets and 1.4 billion with the B occurrence points. And the first time I heard that number, it just sort of blew my mind. I was like, man, I wish that I could visualize that. And thankfully, GBIF allows you to do that. So what does 1.4 billion data points look like? And it's like this. So here we are somewhere in the southern Appalachians, and you can see this heat map. So we've got all of these red areas, and those red areas correspond to areas that have really, really high densities of these occurrence points. And so what I'm able to do with this research is I take these species occurrences and I use them to learn a lot about where these species live, and then I can use that to figure out what sort of climate conditions they experience. And this data, because it's publicly available, really allows a lot of the research. And that's where our collaborators, that are these big data scientists, really make this possible. So I'm going to keep going. There's two different components to this tool that I'm going to talk about today, and the first of these is area of occupancy. So sometimes if you learn about a species, you know it's got a certain range. If you think about that polar bear, its range is up in the northern part of the globe. But for all of these different species, we can use occurrences to try and figure out where it is that they live. And so we use this data from GBIF, the Global Biodiversity Information Facility, and we're trying to figure out where these guys are at. And so let's use one example. This is called the Umpqua Pikeminnow. This is a minnow that's native to the Pacific Northwest. And what we know about this guy is that he lives in a relatively small area, but we have all these different occurrence points that we've pulled from this filtered data set. And so all of this is coming from our GBIF records. And what we're able to do is we can take these individual black points. And so I've got one that I'll pull out here. So this individual little point here, that's one of those records. Maybe that came from a museum. Maybe that was some fisherman that caught it and submitted this record. But we're able to take all of these different occurrence points, put them on a map, and figure out where do these points fall out. Because I'm interested in fishes and freshwaters, I'm interested in sort of where do they live in these watersheds. And so that's just sort of a basin of water. And so what we do is we take these individual occurrence points and we figure out what watersheds do they occur in, and let's count all of those different cells. And so we can get an area in square kilometers, square miles, and figure out what is the range of these individual species. So once we have that, we have sort of this idea of how geographically rare are they. We can put that on a map and we can sort of compare. Some species live all over the place, some are endemic. So they just live in one really small little area. So the second component we've got is climate sensitivity. Take a drink. So for this climate sensitivity component, we have these 5 different climatic variables. And so I love showing beautiful maps. It's a little tough to see, but this is annual precipitation. And so what we're looking at here is precipitation all over the United States. This is coming from another one of these data repositories. This one is PRISM. And so the PRISM Climate Group is making all this stuff available to us so we can figure out with this area of occupancy, we can associate with that all of these individual climate conditions. So finally, what we're doing is we're taking this area of occupancy that I talked about, then I'm talking about climate sensitivity, and we bring them together into one metric. And this metric is ultimately how we're trying to answer that question, how vulnerable are these individual species? So we get our RCS score. This RCS score ranges from 0 to 1. It measures vulnerability, and it associates that with 2 different things. First of all, it's a small area of occupancy, so it's these fishes. If they live in a really small area, we think they're more sensitive and they're more vulnerable. Secondly, there's a narrow climate tolerance, and so if you can imagine a fish that only lives in the southern tip of Florida, he likes that hot weather. A fish that lives in maybe northern Maine only likes cold weather, but if you have a fish that sort of lives across that entire extent, what you find is that it's got a really wide climate tolerance, and we think that that fish is probably better able to exist in a much wider range of conditions. All right, so let's get into some more of the weeds. This is a little bit about the study details that I've got. So we've got the RCS for freshwater fishes. So the first thing that we needed to do, we had to select individual species and find their occurrence data. A little bit more, so we looked at 137 freshwater fishes all across the United States, and so that's just a small subset of the fishes that we were able to look at. There's maybe 800 the whole way across the US. We then calculated that area of occupancy, as I previously mentioned, and we calculated climate sensitivity using these 5 different climate variables. And so That PRISM data set, it's really cool because it allows us to look at different variables. We're interested in these little fishies, and so we wanted to look at precipitation as well as 4 different measures of temperature. And so what we can do, combine that, and we get into a metric. So now let's talk a little bit about some of these results, and I'm gonna overwhelm you for sure because as a scientist, we love to throw our data at you, but I promise that I will break it down. So what we've got here, this is the RCS plot. And so this is really the exciting part for me, is that it's tough to see along this x-axis down on the bottom, but basically we've got fishes all along the 2 sides. So all of the text, those are the 137 species that we looked at. And along the bottom, we've got this RCS score. And so it ranges from 1 on the left to 0 on the right. And as you get closer to 0, those are more common species. So we think that those guys are less vulnerable. But it's really difficult to see this, so I'm going to zoom in on just the top and just the very bottom of this plot. So here we go. Well, we've got maybe the 20 most vulnerable species and the 20 least vulnerable species. And I want to highlight a couple of different things. So first off, there's a lot of different colors going on here. And what I'll point your attention to is we've got gray circles, and that's the rarity and sensitivity values at a national scale. But then we also looked at this in 4 major watersheds of the United States. So we've got these guys that live way out west, we've got guys in the Gulf, guys in the Mississippi, and then over on the East Coast. And so the first important point to make here is that if we identify these species that we figure are the most sensitive to these climate changes, it doesn't matter what region they occur in, nationally and regionally, we find that they're really highly sensitive. And so these are the guys who need the pizza. These are the ones who need our conservation resources. But another thing that we identify is that within these species that are the most common, so of the 140 odd species we looked at, these guys are the most common, but even in those instances, there's some times where these guys are actually relatively rare in a specific region. And so the idea here is that maybe nationally we think that these guys are really protected. You know, if we go back to our pizza analogy, they don't need any pizza. But if you think about these 2 guys in VT colors, what you figure out is that, well, actually, if you look at those specific regions, maybe they need our conservation protection. And so if we're here in the state of Virginia, maybe we just want to look at these occurrences just in our specific area. And if we do that, we might find something different than we do at a national scale. So one last point that I want to make about this is it's not enough to just say, okay, how vulnerable are these guys? I think it's also really important to sort of link that to what we know about conservation status. And so conservation status, what exactly does that mean? So we've got a couple different ways that we can think about it. But I think one of the most common, and if we go back to our polar bear, that's an endangered species. So we've got the Endangered Species Act, which is basically a law that is protecting some of these federally threatened and endangered species. So we've got threatened species and endangered. And if we think again about our pizza metaphor, those are the ones that have the pizza. They've got existing conservation protections. And that's cool, but we're really interested in something else. We want to ask the question, what species have these high RCS values but don't have any listing status? And so what we find is that these threatened and endangered species, it pretty much aligns with our RCS index. We suggested that all of these species were really climatically sensitive, and that bears out. But then we have these other species that don't have any existing conservation protections. And if you look at these species up here, what we find is that these guys are the ones that are potentially hungry but haven't yet gotten to eat. And so I think the real value of this research and what I've been able to learn is that there's sometimes species that fall through the cracks. And the idea is that we don't know a lot about all of these species. And even though the Endangered Species Act does a really good job of identifying some species that really need our help, there's also plenty of species that we don't know that much about them. And so I think for these 10 odd species or so, we've identified that they are really climatically sensitive. And so we think that they need some pizza, and basically we need to go back and try to figure out a little bit more about their biology and try to understand how it is that we can help them. So let's review a couple of points. First, this idea of climate sensitivity, it can differ among regions, especially for these really widespread species. Sometimes a fish that's found in the West might have one sort of climate variability, but if you find it somewhere else in the Mississippi, maybe it's really secure. And so if we're thinking about these conservation practitioners, these scientists that have boots on the ground, they need to really think about where we're doing this study in order to understand how they can conserve these individual species. Another point that I wanted to make, the ESA listing process, those species, they generally have pretty high RCS scores. And so our work sort of supports this idea that yes, these folks, these individual fishes deserve our protection. But lastly, and I think what's the most important part here, is that we've got some of these unlisted species that may be falling through the cracks. So we've got these species, again, highlighted in red, and we really, I think, that these are the guys that we need to be protecting, and I think they're the ones that need our pizza. So with that, I want to thank you all for watching. Really, really appreciate it. So grateful to get to present to all of you, and so thanks so much, and I will take any questions that anybody has.
Thank you so much, Sam. I think it's really fascinating how you can take these big data sets. That's a big data. Have y'all played with big data before? So there's these data sets that have all this information in them, and we have to figure out what to do with that information in order to make it useful to us. And I think you're doing that, Sam.
That's the hope.
So you're you're in biological sciences with this work in fisheries. Do you actually touch fish very often? Do you spend most of your time looking at the numbers and the data?
I think that's a great question. I almost came in here wearing my chest waders and my floppy hat, but it's a hot room, so I'm really glad that I didn't do that. But I try to spend as much time out in the field as I can, but I think something that's really interesting with this work is that COVID threw us all a curveball. This was initially maybe going to be a side project for me, but the reality is that when your field work gets canceled, you need to sort of figure out what are other directions that you can go in. And this sort of started as like maybe an opportunistic thing. But I was so grateful for all of this big data because for the last really 2 years, I've been able to sink my teeth into this, and it's been a really awesome appreciation that like this data is so unbelievable, and you can ask a lot of really excellent questions without ever having to get in the stream. I still love the stream, and I look forward to when I'm able to get back out there, but really grateful for this opportunity for sure.
And did you find, there's more questions in the back. Let me come back here, but I have more.
Absolutely.
Let me come ask this one.
Hey, thank you, Sam. Can you tell us a little bit about the 10 or so species that you identified that really need help? Are they from one part of the country, or are they little minnows or big fish or things that we would recognize if you told us their names?
Yeah, so I don't know the exact 10 species, but in general, they are little small minnows that you've probably never heard of. I think there's a pup minnow that is only found in one really small area. I don't know that there's any names that you would recognize, but I think the part of this, I think, is that, and the reason I use that mussel example is that oftentimes they're sort of these humble fishes, these humble organisms that you don't know much about, but nevertheless, they have some real important ecological value. The way that we calculate area of occupancy, that's a really important part. It's 50% of this, and so you have species like maybe bass or trout that folks are maybe a little more familiar with. Maybe you've got salmonids. And if these are fish that sort of have really large areas, because of that, they've got relatively large area of occupancy compared to these really small endemic species. There's also some sturgeon in this analysis. And if anyone knows anything about sturgeon, they have these massive migrations. And because of that, their area of occupancy is really, really large. And so in general, any of those species that move super, super far, this assessment would suggest that they're relatively common and probably not as vulnerable. But again, those little fishes, sort of those non-game species, are probably most of those 10. I think that's a great question. That's one, I think, one of the problems related to the previous question. I would love to get out and get to handle these fish, but they're just sort of a species name in a spreadsheet. But the reality is that they have a lot of ecological value, and I think it's probably good for me to think more about who those 10 are. So thanks for the question.
Excellent. Do you have a question? No? More back here? Yes, ma'am. I'll hold the mic.
What made you decide to make this your project? What made you interested in it?
That is an awesome question. I think as a graduate student, sometimes projects just kind of fall into our lap. And I think this was part of that. But it was initially just going to be sort of a little study, but I really was able to sink my teeth into it. And so I did my master's in fisheries and wildlife. And so I was really interested in sort of the ecology of freshwater fishes. And so because I had that experience, I was sort of primed to be able to think about freshwater fishes, but I've never considered sort of the applied side of this and thinking about, well, not just what do we know about fishes, but how can we help protect them? And so for me, I think it was really exciting to get this project and to realize that, oh, I can make a difference. I can actually help some of these fishes rather than just sort of knowing some of their basic biology. So I think I was excited from this project on day one, and after 2.5 years to still be excited about it, I think it was a really good fit for me. Thanks for the question.
I think that's a really good point about science, is that sometimes we get started on a project and think it's going to be small.
There's always more questions,
There's
absolutely.
always more questions. I'm just checking in the online list here. Did you do your undergraduate work? Undergraduate is the first time you go to college. Okay. Did you do your undergraduate work here, or did you study that somewhere else?
So I studied my undergraduate at Susquehanna University. So it's a small liberal arts college in central Pennsylvania. And I was fortunate enough to work with brook trout, which are a really well-known, I think something like 11 states, it's their state fish. And so that's an example of a fish that is probably not as vulnerable, even though we know that climate is affecting these fish. It's sort of found all throughout the East Coast. And so that was my first real exposure to freshwater fish, freshwater ecology. And so I think since then, I've been hooked for sure.
Hooked. Get it?
Everyone loves fish puns, right?
We love fish puns. What else? Did you have a question? Got one.
What would next steps be then for these fish that you determined are highly vulnerable? Does the Endangered Species Act look at this kind of data with climate change, or do they have pre-climate change qualifications for being endangered?
No, so that's a great question, and I'm glad I'm able to sort of expand on this. And so, for the purposes of this talk, I definitely kept out some of the real nitty-gritty. And Abby Benson, who is our collaborator with the U.S. Geological Survey, she'd be the first to say that this work is under review, and the USGS definitely does not want to, you can't take this and turn it and just say, oh, this is going to be an endangered species. But I think the reason that the USGS is so excited and sort of supporting some of this work is that it's another tool in the toolbox. And so for a species to get listed as either threatened or endangered, that is a huge process. And even before then, it sort of gets listed as a candidate species. And so the idea here is that these are maybe candidates to become candidates. And there's still a lot of other work that needs to go in there. But we think of these as species that are potentially flying under the radar. And so with those 10 species, it's, even though there's a lot of data that goes in, it's still relatively simple. And we're not even considering the direct impacts of the exposure. We're just sort of asking who's predisposed to potential impacts. And so if you have some species that only occurs in a really small area, it is geographically rare. But there's lots of ways to think about rarity. And so one of the others is, what is their population abundance? So maybe it lives in a really small area, but it's the only fish and it outcompetes everybody, and it's actually really secure. So even though we identify it as vulnerable in our metrics, the USGS and some of these other agencies, the Fish and Wildlife Service, they would identify that as actually relatively secure. And so these 10 species, we think that they need a little bit more study. And so, but as you sort of peel back the layers of the onion, you might recognize that maybe half of those aren't actually as vulnerable as we initially predicted because they're secure in some other means. But even if we identify one or two species that, probably have flown under the radar and that do warrant additional conservation status, this is an effective tool. And so I think, there's lots of ways to address a problem, and I think this is just one of many tools that hopefully will lead to some protections for these fish if the agencies ultimately decide it's warranted. So glad I can expand on that a little bit, and hopefully that answers the question.
What a great way to show how big data can inform policy, but it takes somebody asking the questions, right?
Absolutely.
I love it. I love it. Asking great questions. So we are at time. So what we're going to do now is I'm going to ask you all to continue your conversation in the lobby. We do have an evaluation. Again, for those who are under 18, we'd love to talk to you about your input from this. And also be sure that you get a goodie bag. There is a robot to put together in there and a sticker. It's a really cool one. Looks just like this one right here. So be sure you get one of those. Put that robot together when you have time. Okay, it's got a lot of little parts. So thank you all for being here today, and we'll see you again soon. Thanks for coming to the Virginia Tech Science Festival. Thank you, Sam.
And thank you all.